Like the ancient Amazonians of centuries past, farming companies today are using a carbon-rich material to enhance soils or purify polluted wastewater. It's called biochar. Up next, we take you to Florida, where farmers and geochemists are creating biochar through an age-old practice. Here's the story.
Our company's name is Green Dreams, and we're an edible landscaping company focused on regenerative and holistic practices.
Green Dreams Landscaping at Sandhill Farm is located near Spring Hill, Florida. Their farm is on some of the poorest soil you can find, sand.
The basis of our farming technique is to build the soil and build soil life. Organic farming really revolves around soil microorganisms and beneficial fungi.
As organic farmers who use a holistic approach, also known as permaculture, they were looking for ways to improve their soil amendments to make them more permanent. The answer, biochar.
It's using waste products that we're having problems to get rid of, that are difficult to dispose of. Often people are paying money to dispose of them, and we're turning it into a product that's carbon neutral and carbon negative. It's building soil. It's providing a home for this crucial soil life.
The success of biochar at Sandhill Farms led them to make their own biochar from lumber scraps they recycled from a local mill. They made a kiln designed to burn organic material in a low-oxygen environment.
The kiln that we're using is called an inner retort chamber, and that's basically a two-stage process. There's an outer chamber, which is a large stainless steel container, and an inner chamber is a sealed stainless steel container. And the process is called pyrolysis, where the outer container is vented, so it's allowing air to come in through the bottom and out the top through a chimney. And that inner barrel, it's surrounded by feedstock, surrounded by wood or other flammable materials. And that's heating up this inner sealed barrel. And through that process, you're basically gasifying that wood and turning that wood into pure carbon or charcoal.
It takes about 3 hours to complete the process and end up with char. After being allowed to cool, this carbon product is charged with biological material used at their organic farm.
So what we have here is about 8 batches of finished char. This is the finished product. Our next step with this would be to crush it and then charge it with a compost tea manure slurry. A quality finished char should sound like glass.
Owner Pete Canaris has invested heavily in biochar.
I really feel that biochar, is the future of, sustainable agriculture. It's something that's, obviously regenerative. It's going to be there for the long term. It could be, the next big thing, in my opinion.
This next big thing has attracted the interest of scientists. Andrew Zimmerman is an associate professor and an organic geochemist at the University of Florida.
I got started thinking about and studying about how microbes eat organic matter or don't eat organic matter. That led me to my interest in charcoal, which is really, combusted organic matter, the product of fire, because that's a very refractory type of organic matter. That means it stays around a long time. It's hard for microbes to eat it.
Dr. Zimmerman's research entailed an in-depth examination of material used to create biochar.
My first studies were to look at different types of biomass, so plants and grasses and different types of wood and grasses, and make those into biochar or charcoal at different temperatures, and then look at what types of variations in the chemistry of it, as well as how stable it was.
He creates his biochar in a controlled environment.
I take different types of biomass and I put it in a oven. It's constructed in the shape of a tube so I can run gas nitrogen. If I run nitrogen through it, that gas does not react and it really keeps the oxygen out. I make biochar typically at temperatures ranging from 250 Celsius to 700 Celsius. And the higher the temperature, the more pure your charcoal.
The biochar is then evaluated for chemical properties.
To do that, we have to dissolve it, and then we can put it into an instrument like a chromatograph to look at all the molecules. We also are interested in what can naturally leach from the biochar. When you put it out in the fields, you're going to have rain and water, flowing through it. If we're going to be able to use it for carbon sequestration, we certainly have to know how stable it is.
One potential major use for biochar is carbon sequestration, where CO2 is prevented from entering the atmosphere.
Instead of letting our residues from agriculture and from lumber decompose and return back to the atmosphere and be CO2 where we don't want it, we can make it into charcoal and then put it into soils, and it will stay there a long time, and we can actually build up the carbon in the soil and keep that carbon out of the atmosphere. When biochar is really widespread, say through the United States, it could probably offset maybe 10 to 20% of the country's carbon emissions.
The use of biochar is an ancient practice. It was recently discovered that pre-Columbian Indians in the Amazon developed a rich organic soil called terra preta over the course of thousands of years.
Terra preta actually means black earth, and these black soils that are rich in organic matter and very good for growing things, unlike most tropical soils.
Dr. Zimmerman has traveled to South America to see these soils firsthand.
People living in the Amazon 1,000 years ago had some technology, some way of adding the carbon to the soil so that it retained the nutrients and served as a good agricultural soil. And so we're trying to rediscover that technology and apply it, have new applications for it.
The folks at Sandhill Farms are using biochar because Florida's sandy soil has a low ability to hold in nutrients.
The biggest component of biochar that makes it so important is a term called cation exchange capacity. And this is a term that basically means the soil's ability to hold nutrients. So we could put out a truckload of manure and organic fertilizers, and that would be great, the plants would grow, but it's quickly getting leached through the system by our heavy rains we have here, and it's not really getting stored long-term in that soil. Biochar has many, many times greater cation exchange capacity. Once that charged biochar is put into the ground, any of those nutrients are stored there and provide food for that beneficial soil life, and then are slowly released back into the system, for thousands of years potentially.